Hello students, in previous lecture we have discussed on the basic terms related with the sets and the writing methods of sets, that is list method and rule methods. These are the different methods of writing the sets and examples based on those methods we have solved from practice set 1.1 in previous lecture. Then today we are going to discussing about the different types of sets. That is, see here, there are different types of sets and these types of sets we will discussing with you, that is taking example of those types of sets. Then first one, that is type of set, that is singleton set. Singleton set. Then see here, the singleton set, the name itself indicates single, that means one. Then what is singleton set? It is a set which contains only one element. That means any one of the element should be there. That means the set which contains one element in it is called as singleton set. Then see here, example of singleton set is P is a set of, that is the natural number which is neither composite, which is a set of natural number which is neither composite nor prime number. That means here, see here, P is a set of 1. That means it contains only one element. 1 is a member. That means P, in which element that P1 belongs to P set. And here number of elements in P set is 1. Then it doesn't matter which element is there. That is, but that set which contains only one member should be there. Then P is a singleton set. Then one more example, that is A is a set of, it is a set of even prime number. Then see here, all of you have the prime number set, odd number set, even number set, natural number sets, whole number sets, and integer number set, real number sets, as well as that is rational number set. We have discussed in previous lecture. Then see here, the prime number which starts from 2 and which is even. But if we find out the prime numbers from the natural numbers, then there is only one even prime number is there. That is here, A is a set of 2. Then you may write the prime number set. Then you can find out that there are all members are even numbers, prime numbers. But only one, that is 2 is all members are odd prime numbers are there. But only one member is, that is even prime number is, that is 2. Therefore this A set contains number of elements that is only 1. That is the symbol which is used. Number of elements in A set is equals to 1. That means here 2 is only one member. Therefore it is called as singleton set. Here P and A are the singleton sets are there. Then second one type, that is empty set or null set. Then see here, empty means vacant. That means here the name itself indicates that the set which does not contains any element. No elements are there in the set of that empty set. Then for example, B is a set of all prime numbers less than 2. Then see here, prime numbers which starts from 2, 3, 4, 5, 2, 3, 5, etc. Therefore, the prime number which is less than 2, there is set B is a empty set. No members are there in this set. Then one more example, that C is a set of odd numbers lies between 1 and 3. Then here C is a set of odd numbers. 1, 3, 5, 7, 9 are the odd numbers. And between 1 and 3, no any odd number is there. Between 1 and 3, there is 2. 2 is an even number. Therefore, C is an empty set. No any elements are there in the set C. Therefore, B set and C set both are empty set. Then that empty set, that is denoted by, B is an empty set, therefore it is denoted by this sign. That means B is an empty set. This sign is also known as phi. Phi sign is used for every empty set. That means here C is an empty set. Then one more type, that is third type of set is a finite set. Finite set, then see here, that set which contains the elements, that elements can be countable. That means we can count the number of elements in those set are called as finite set. Then that means the number of elements in those sets are limited, which is countable, that are called as finite set. Taking one of the example of this, that is P is a set of, that is perfect square, which is less than 100. Therefore, P is a set of perfect square of the numbers, that is square of 1 is 1, square of 2 is 4. Therefore, 1, 4, 9, 16, 25, 36, 49, 64 and 81. These are the perfect squares, and which is less than 100. The next perfect square is 100, but P is a set of perfect squares which is less than 100. Therefore, we can count the number of elements in P set is, see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means there are total 9 elements are there. Therefore, P is a finite set. Similarly, we can write one more set, that is A is a set of letters in word Bharat. Then see here, A is a set of letters in Bharat, that is B, H, A, R. Here A comes again. We should not write the elements twice in the set while writing the set. Therefore, that A get repeated here. Therefore, I am going to avoid that, write that elements in the set, because it comes twice in this word. Therefore, here T, and there are total 5 number of elements in set A. That means we can count the members of set A and set P. Therefore, P and A are the infinite sets. These are the finite sets. That means members of these sets we can count. Then, or it is limited. Therefore, these are the finite sets. There are many more examples are there, which are the examples of finite sets. We will discussing it about later. Then fourth one type, that is infinite set. Infinite set, see here, infinite set means, infinite means, all of you aware of that, we can't count the last member, or we can't count the members of that set. That means there are unlimited members are there, uncountable members are there in the set. Then that sets are infinite sets. That means we can't determine the last member of those set. All of you studied about the natural number set. That is 1, 2, 3, 4, 5 and dot dot. Dot dot means there are uncountable members are there. And natural number set is an infinite set. Similarly, whole number set 0, 1, 2, 3, 4 dot dot. That means whole number set is also infinite set. Integer. Integer which contains 0, all positive numbers as well as all negative numbers. Then see here, -1, -2, -3 and -4, -5. Uncountable negative numbers are there as well as uncountable positive numbers are there, and 0 together is an integer set. That means integer set is also infinite set, as well as a real number set and rational number sets are also infinite sets. That means there are infinite members, uncountable members are there in the sets of real number and rational numbers. Then that is about the different types of sets. And one more concept now I am going to discussing with you about the set. That is here the sets. There are different types of sets are there, in which there are few equal sets are there. Equal sets. Then see here the concept of equal set. I am going to discussing with you by taking one of the example of it. See here, A is a set of prime number less than 5. Then see here, all of you aware of the prime numbers. One is a neither composite nor prime number. Therefore 2, 3, 4 is not the prime number. 5 is a prime number, but here A is a set of prime number which is less than 5. Therefore here members of set A is 2 and 3. Therefore there are total number of elements in A set is 2. Total 2 members are there. Similarly, one more example, that is B is a set of natural number lies between 1 to 4. Therefore, B is a set of 2 and 3. See here, set A and set B. Observe that set and elements in those sets. Here, the members of set A and members of set B are equal and same. That means every element in the set A is present in set B and every element in set B is present in set A, and equal number of members are there. In set B there are only 2 members, as well as in set A 2 members are there. But here members or elements are also same, not only equal but same. Therefore, here A and B sets are equal set, which is denoted or represented like this. Here A and B sets are equal sets. Then see here one more example, that is C is a set of 1, 2, 3, 4, 5. Here 2 and 3 members are there in the set C, which is present in set B and set A. That is 2 and 3 members are, both members are present in set C. But here the members of B and C are not equal. That means therefore B is not equals to set C, and A and C are not equal sets. That is about the equal sets and unequal sets. And this property or these concepts and types of sets, we will solve the examples which is based on these concepts from practice set 1.2. Then see here the practice set 1.2, in which question number 1 that is given, that is practice set 1.2. Question number 1, that is write or identify which of the following are equal sets. Then we have to find out the equal sets from following sets given in the question number 1. Then see here there are 3 sets are given. 3 examples of sets are given there. That is A is a set of all x elements such that 3x minus 1 is equals to 2. Then that sets are given in rule method. Therefore, we have to write that A is members of those elements. That means A set should be written in list method. Then we can identify whether those sets are equal or unequal. Then see here x. Then we have to find out the value of x by solving this equation. See here equation is given. That condition is given in the form of equation in this set A. See here the equation 3x minus 1 is equals to is given here. We will solve to find out the value of x. Therefore here x 3x is equals to 2 plus 1. Therefore 3x is equals to 3. Therefore x is equals to 3 upon 3. Therefore here x is equals to 1. That means here set A is in which member is 1. Then B is a set of all x elements such that x belongs to natural number. That means x is a natural number and that x should neither prime number nor composite number. Composite number. Therefore, B is a set of all natural number which is neither prime or nor composite. Only one is a natural number which is neither prime nor composite. Therefore, see here B set which contains only one, that is one is a member of that set B. Then C is a set of all X members, that is such that here X belongs to natural number and X should be less than 2. That means here C is a set of all natural numbers less than 2 and the natural number less than 2 is only 1. Therefore, 1 is a member of this set. That means see here, by observing set A, B and C, we can write A and B are equal number set, B and C are equal number set, and A and C are equal sets. See here, A, B and C all are equal sets because these all contain same and equal members. Then question number 2 you have to solve because that is also based on equal set concept. Then question number 3 I am going to discussing with you few examples of it. See here question number 3, that is which of the following is empty set. Then first example, that A is a set of all A members such that here A belongs to natural number. That means A is a natural number and that A should be less than 0. Then see here, natural number starts from 1, 2, 3, 4, isn't it? No any member which is less than 0 and the members which is less than 0 is -1, -2, -3. These are the numbers which is less than 0. There and -1, -2, -3, these are not the natural number. Therefore, A is empty set. No any natural number which is less than 0. Therefore, A is a empty set. One more example here given, that is C is a set of all X elements such that 5X minus 2 is equals to 0 and X should belongs to natural numbers. That means again here condition is given in the form of equation. Then we have to find the value of X. By solving this equation, 5X minus 2 is equals to 0. Therefore, X is equals to 2 upon 5. And here the value of X is 2 upon 5. But here condition, one more condition is given here. X should be belongs to natural number. That X should be belongs to natural number. But here value of X is 2 upon 5 and 2 upon 5 is not the, it is not the prime number, it is not the natural number. That means here value of X is not the natural number. Therefore, C is a empty set. Then last example from question number 4 I am going to discussing with you. That is question number 4 is given here. Find out the following finite and infinite sets. One of the example is given in question number 4, that is set of laboratory apparatus. See here, how many apparatus are there in the laboratory, and those apparatus we can count. There may be 1,000 apparatus may be there, or 1,005 member apparatus may be there. That means we can count the apparatus in the laboratory. Therefore, it is a finite set. It is an example of finite set. As well as one more example, there are lot of examples of finite sets are there. I have already discussed with you. That is days in the week. There are 7 members in the week. 7 days are in the week. That is finite set. Months in the year. That is the blackboard which is present in the school. The students in the class 9th B, we can count those members. These are the examples of finite set. Then one of the example is given here. That is A is a set of prime numbers. Then see here, all of you have written the prime number set, odd number set, even number set in previous lecture. And then if we can write the prime number set of set A, then see here, start with 2, 3, 5, 7, then 11, 13, 17, 19, and so on, ... means there is uncountable members are prime numbers are there. That means last prime number we cannot determine. Therefore, prime number set is also infinite set. Even number set is also infinite set. Odd number set is also infinite set. Natural number, whole number, integer, real number set, rational number set, irrational number sets are also examples of infinite sets. That is about the types of sets and examples which is based on it. From practice set 1.2 we have solved this. Then try to solve the remaining examples from practice set 1.2. Then we will discussing about the few operations, few fundamental concepts, operations on sets in next lecture. Thank you.